Got another example about taking a piecewise function and expressing it as a combination of Heaviside functions. So in this example, I've got kind of non-constant pieces. You should watch the video that I made on what if you have a couple constant pieces and how to split it up that way. Same kind of business here. So this function f, it's t squared if t is between 0 and 2, and it's negative t if t is greater than or equal to 2. And we're supposed to, again, express this as some combination of these step functions that are Heaviside functions. So just to give you a picture of the graph of what f is here, he looks like this over on the right-hand side on Desmos. So it's part of that parabola, and it's part of this negatively sloped line. So the blue tells me what are the spots where the switches are supposed to turn on and off. So where are the steps at, in other words? So the useful Heaviside functions are u0, which is 0 if t is to the left of 0, and 1 if t is to the right of 0. And just to plot that, that's this step function right here. And remember, you're thinking about that perhaps as a switch that turns on at t equals 0, and when it does turn on, it just emits like a constant power of 1, if you want to think of it that way. And the other time that a switch turns on would be, say, t equals 2. So u2, which is 0 if t is to the left of 2 and 1 if t is to the right of 2, that would be the switch right here. So what we're going to try to do again is we're going to try to use these two step functions, u0 and u2, in order to try to rewrite f of t. So how are we going to do that? So I look at my function here, and we're just going to try to look at it piece by piece. And if I also look at my picture up here, it doesn't hurt anything as far as if I just think about, there's nothing to the left of 0 in that picture. Why don't we just say the value of the function is just 0 there? So that won't hurt anything. So to model the green, what we ought to do then is just take u0 here, and I'll just multiply it by, well, I really want to have a t squared there if t is to the right of 0, right? So why don't I just multiply by t squared? So we use t squared times u0. And just to show you that, right, if I took t squared times u0, you see when I add that graph on there, that picks up the red parabola. So the purple is t squared times u0. And again, the left side, we're just going to say, all right, there's no power there. So nothing there versus 0 there. It's okay. Same thing as far as interpretation goes. All right, so we should be happy. We've kind of modeled one part of our function here. Maybe you already noticed something too. Like a switch is going to turn on at t equals 2, and I want to get down to the red line. But you see that like my t squared times u0, it doesn't just stop at t equals 2, right? Like I get more of this parabola way past t equals 2. So I'm going to have to account for that when I think about how to model the next piece of the red. And so, again, kind of naively, what you might be thinking is, all right, I should just, take the formula of the thing I want, the minus t, and so I should just take the formula for the minus t that I want, and I'll just multiply this one by it that turns on at 2, right? And like that's, you're thinking about multiplying things kind of the right way, right? But the problem is, again, is that you get some t squareds to the right of 2 also, right? It's not just negative t. You've also got some t squareds here. So in other words, what I'm telling you to do is I need to cancel out the part of the parabola here that is to the right of this dotted line. I need to cancel that out so that it doesn't affect how I model the bottom piece. So what are we going to do? How are we going to cancel it out? Well, I'm just going to subtract t squared, right? I'm just going to subtract the equation for its graph. And so what we ought to do then here is, like I said, not just multiply u2 by negative t, I'm going to multiply u2 by negative t minus t squared. So in other words, when I turn the switch on at 2, I'm going to have minus t squared as the output to the right of 2. So again, as the step function goes, its formula is 0 to the left of 2, and now t minus t squared to the right of 2. I'm just going to subtract t squared in order to, again, chop off that piece of the parabola that I don't want. So when I put this together now, my answer should be t squared u0t plus minus t squared times u2 of t. And just to maybe show you how you can check your work in case some of this still feels a little funny, maybe you weren't getting it from the picture right, just to check that this works also, let's think about what if we wrote out what the green and the yellow actually are, and let's try to write out our piecewise functions so that like the intervals over which I'm considering, that they match every time, right? So that what can I do? Well, I want to add these functions together, and so what I would do to add them is I would just kind of add the formulas for the corresponding domains, so that this piece would be 0 plus 0 if t is to the left of 0. Well, that of course is just 0. And the next thing I see is, well, I should do t squared plus 0 if t is between 0 and 2. And so when you add t squared and 0, you just get t squared. And then last, I should get t squared and plus negative t minus t squared whenever t is greater than or equal to 2. And of course, when I add these together, this is how you can kind of see that the t squareds will cancel and you just get the minus t that you want there. So that's how you can kind of check your work, check your algebra here.